Good day, everyone. Thanks for tuning in to listen to my presentation. My name is Đinh Hoàng Việt. My ID is 3369875. My supervisor is Dr. Lim Chong Lai, and my project data is exploring printing parameter factor in 3D printed honeycomb sandwich structure. And for the next slide is about content. The first introduction, background, aim and objective, literature review, methodology, result and discussion. For the introduction and background, what is honeycomb structure and what is additive manufacturing? The honeycomb structure is widely used in engineering and manufacturing due to it is lightweight and low cost. It consists of interconnected hexagonal cells that form a solid structure. The honeycomb sandwich structure is highly efficient in terms of material utilization, reduced structural weight, and is used in various industries. It typically has two faces and a honeycomb core made of aluminum, stainless steel, plastic, and composite material. For the figure 1 is honeycomb structure. And what is additive manufacturing? Additive manufacturing enables the products of structurally complete design and customized properties in structure encompassing mechanical, thermoelectric, and acoustic characteristics. However, the quality of 3D printed product is significantly influenced by various printing parameters, including printing speed and printing orientation. This study aimed to investigate the impact of different printing parameters on honeycomb structure through experimental method. The effect of the printing parameter on the final properties and performance of the printed honeycomb structure will be examined through semantic analysis and evolution. For the figure 2 is 3D printing machine. And the next slide is aim and objective. For the aim to determine printing parameter factor of the mechanical performance of the 3D printed honeycomb. An objective to determine the 3D printing parameter via literal study. Identify a selected honeycomb structure. Conduct the experimental study on the mechanical performance of the 3D printed honeycomb chamber. For the next slide is the Gantt chart. The figure 3 is Gantt chart for my final year project A. And the figure 3.1 is Gantt chart for the present project. And next page is literal review 1. Printing parameter, infill density, printing speed, no temperature, bed temperature, and the figure 5 is some schematic presentation of the FDM fabrication processing. And next page is literal review 2. Benefits of honeycomb sandwich structure. A sandwich structure is from a laminated composite formed by two stiff facing at the top and the bottom. High specific strength, stiffness, and lightweight. The figure 3 is honeycomb sandwich structure. At the middle is honeycomb core, and it will be covered by two faces on the top and the bottom. Factor affecting 3D printing product. Various factors such as printing process parameter, material composition, and post-processing affect printed product, mainly manifest in accuracy, processing time, and material properties such as ultimate tensile strength, elasticity, modulus, yield strength, and impact strength. Printing factor affecting the honeycomb structure included high layer height, printing speed, temperature, raster angle, and honeycomb shape. For the next by methodology flowchart, start with literature review and determine the printing parameter, identify honeycomb structure, and after that, I will create a 3D printing file by using SolidWorks. And after that, I will convert it to STL file. And next step is put it into the 3D printing machine. If printing quality is not acceptable, I will reprinting it again. And if printing quality acceptable, I will go testing experiment and data collection. After that, I will analyze the data and will give some conclusion and recommendation. For the next page is printing parameter. For the figure 7 is honeycomb core. So the table 1 is the dimension for the honeycomb core. For the cell wall thickness is 1.5 millimeter, and cell size is 5.5 millimeter, and core thickness is 10 millimeter. For the table 2 is printing parameter. Printing parameter with the raster angle is 0 to 90 degree for test 1. Test 2 is 45 minus 45 degree, and test 3 is 0 90 degree. Test 4 is 45 minus 45 degree, and the node diameter is 0.2 mm, and layer height is thickness, and layer height is 5 mm. Especially the printing speed for the test 1 and test 2 is 300 millimeter per second, and test 3 and test 4 is 400 millimeter per second. So for the test 1 to test 4, the field density is 20%. For the table 3 is property of material of printing filament used in this research. So in this research, I have used PLA for my printing. The printing temperature for the PLA is 190 to 200 degrees Celsius, and the bed temperature is about 15 degrees Celsius. And for next way is result and discussion. For the figure 6 is my design for honeycomb structure. I have been used the SolidWorks create the honeycomb structure with the length is 130 millimeter and the width is 55 millimeter. And after that, I will convert it to the ETL file. And the figure 6.1 is 3-point pending test machine. The 3-point bending test for determine the flexural properties of the honeycomb structure according to the ASTM 3369. For the next page is printing result. For the figure 8 is my honeycomb structure after finished printing, and the figure 9 is after the test finish 3-point bending test. The honeycomb will crack at the middle like the figure 9. So the next page is the test result. For the figure 9 is straight and strain under 3-point bending test. On the symbol has a linear train at first, but as they reach the maximum stress value, the curve began to drop and determine the correct indentation of time the specimen. The impact of printing speed on panels with a honeycomb structure was noted. The highest load capacity is found in honeycomb sandwich model printing at 300 mm per second speed. On the other hand, the structure printing at 400 mm per second speed had lower load capacity. For the testing result 2 is comparison of maximum stress. The maximum stress levels of two honeycomb sandwich structure were tested, which one printed using 090 raster angle and the other using minus 45 raster angle. At a printing speed of 300 mm per second, the maximum pressure chart demonstrated that the 090 printing angle had greater bearing capacity than minus 45 and 45 raster angle. Additionally, it was shown that stress tolerance was lower at 400 mm per second printing speed than the 300 mm per second. The maximum stress was around 0.88 megapascal at 300 mm per second printing speed and 090 printing angle. The maximum stress was around 0.86 megapascal at 400 mm per second printing speed with a raster angle of 090 degree, whereas at 400 mm per second printing speed and the symbol raster angle of 45 minus 45 degree, the maximum stress was approximately 0.84 megapascal. For the testing result 3 is figure 11 is failure during the test. In the test, when this lot is with the maximum stress, the honeycomb will crack at the middle. And next slide is about discussion. The 3D printed sample with 300 millimeter per second printing speed and 090 degree printing angle have a higher resistance to the bending with a maximum stress of 0.88 megapascal. All the project objectives have been successfully achieved. So from the results, so in the figure 10, the stress strain behavior under 3-point bending load demonstrate that raster angle and material type have little effect of the 3D printing honeycomb structure. And higher raster angle, so higher resistance to bending. This is aligned with finding from the literature review. When you using raster layer short carbon fiber in microstructure of FDM printed chamber continue to align strongly with the direction of material deposition. This alignment is essential to fabrication and properly influence the FDM specimen mechanical characteristics. For the next page is the conclusion from the conducted literature investigate the 3D printing parameter and selected honeycomb structure have been determined. Printing speed had considerable impact of the load bearing capacity of the honeycomb sandwich structure, according to the finding of the study on the mechanical performance of honeycomb sandwich structure. As a result, selecting the suitable material and raster angle may regulate the mechanical properties of FDM fabricated honeycomb structure. The stress strain behavior on a 3-point bending load demonstrate that raster angle and material type have little effect on manufacturing condition, and the combined effect of raster angle in increased printing speed impact the specimen stress resistance and failure spots. So this reference for my whole report writing, and the next slide is thank you for your listening my presentation.